Hi everyone, this is Dimitris from OSRC. After many requests on the YouTube channel, the Facebook and comments, as well as the forum post, I thought sitting down and discussing the features of this beautiful remote control system which I built. Now, I don't know if I'll be able to cover all of the topics which were mentioned in the forums and comments, but I will try my best and cover as much as possible. Before we start, I just wanted to make some things clear about the system so that everyone understands from the beginning what we are talking about. The OSRC system is called a system because, unlike typical remote controls which are currently on the market, OSRC is an investment which you make just once. Why is it an investment? First of all, the system itself is modular, meaning that when you buy even the basic system with as little features as possible, you are still getting a very functional system which is more than other systems in the same range. When I'm talking about range, I'm talking about price. Now, when we are talking about modularity, the basic features which I wanted to make clear when I was developing the remote control was the shoulder switches, which you can see up here, which besides the ones which are on the control now, there are many others which we'll talk about later on. So when we're talking about modularity, we're talking about the switches which you see on the shoulders. We are talking about the RF modules. Now, we shall talk about the RF system itself and the frequencies later on in this video. So I'm just mentioning the modular features of the control. So the RF, the shoulders, and also the other aspect of modularity is the FPVC system. Now, the FPVC system, there are some modules which are more advanced than others. We shall discuss that later on. Now, besides the remote control, I just want to clarify why it's called a system. Unlike traditional remote controls which are used to by now, because I am a flyer myself, and I started flying helicopters mostly in the beginning. My first helicopter was Raptor 60 with Nitro, and then I upgraded to 90, so I learned my RC a long time ago on helicopters, and then I started flying planes and so on. When I designed the system, I designed it the way I wanted the system to be. When I'm talking about, because today the RC in general is not the same as it used to be, let's say 10 years ago. There are multi-rotors now, there are UAV systems which are more affordable, and many other things which people want to do on their remote control and do with their RC. So based on my knowledge, I wanted to create a system which could combine all these features in one unit, so that you don't need to buy extra hardware but build upon what you already have. So when you purchase OSRC, you're purchasing something which you will have for a very long time. And by saying that, I mean that even if you buy the cheapest assembly of features possible, you will still be able to upgrade them later on and add upon this, and all of the modules, even the future modules which will come, they will also be completely plug and play with the system you already have. So there won't be any worry about compatibility or any other issues. Besides that, because the system is open source, naturally I made a user interface myself, which is basically, yeah, you see the sticks move, yeah, and many people like that. Anyway, the user interface itself works fine, the electronics work fine. As you can see here, the high-tech which I have now is turned on and it's configured for a high-tech. But software-wise, I have a system of my own which I already built, and it works fine. There are many aspects which I will talk about later on, but for now, so that you just know about what I'm talking about, the system is open source, meaning that even though for the time being I'm working on it myself, many people can join in and start building upon what I already did, and perhaps maybe make even things which I didn't think about. So let's talk about the list of features which I put together, the things which I want to talk about based on the comments and all of the requests which I had through emails, so that we can clarify a lot of things which we control can do, and answer some of your questions which you posted online. So let's begin with the specs. Now, the basic system, when I say basic, the lowest things which you can put on OSRC. The basic system has a monochrome LCD, which shows you the main interface for your mixes and everything else. We have the switches, and we of course have the RF compatibility behind. Now, there are 12 to 24 shoulder buttons which you can add. What I mean by that is that although you see here now there are 4 on the left and 4 on the right, each shoulder has the ability to have up to 12 on each side, meaning that even though it's impossible to put 12 switches on one shoulder, I build it this way so that the hardware is there, but it can be upgraded later on. So because it's not just an input-output expander which is on the shoulders, but it's actually a separate microcontroller. Besides the switches, we can put things like additional inputs here for digital data, or maybe an extra LCD. Things which I may not think about when I'm building the first version, but things which will come in the future. So you can put up to 12 switches on the right and 12 switches on the left, input-output signals. Also, there are 2 analog inputs on each side, so you can put additional pods or things which are basically sending you analog signals. Now, there are 2 main pods on the unit itself, which you can assign to pitch on pitch curves for your helicopters, which you can assign for many other things. So those are always on the system itself. Now, there are 18 front buttons on the device. When I say front, I mean the interface buttons, the right and left quad buttons, and also the FPVC buttons. Now, I will talk about that later on, but we're just talking about the specs now. Also, there are 2 buttons on the back. You can see them here. These buttons are also assignable as well as everything else. But those buttons, when I was building the system, I was thinking about gears, landing gears, which you can flaps assign to the system itself, so they are very convenient for you not to move around your fingers when you're flying, want to quickly switch something. Now, the RF modules on the system are switchable, meaning that besides the high-tech, you can also add a Futaba module and a JR module. Now, the Futaba, JR, and high-tech, there are many other like FR-Sky which are JR compatible, which will also work with this. Besides the RF modules which come with the unit, we have I built an internal RF system inside the system, the unit itself. It's behind, basically it's behind this module, there is another RF modem. And that modem connects to one of the antenna connections on top. Now, there are 3 antenna connections on the unit itself. Why there are 3 connections? Well, the middle one, as you can see here, is the primary. And the primary antenna connection is the one which basically connects your internal OSRC RF modem to an external antenna. Now, these connections are naturally, you can take a standard whip antenna out, and you can connect a bigger antenna or a cable or something else that you might want to connect to it. There is also a secondary antenna. Now, the secondary signal is, for the time being, it's floating. It's not connected to anything, but the board itself, which houses behind this module the RF modem of OSRC, also has a space for a very long-range RF modem which works on 900 megahertz. It's just for experimentation for now, but I thought of adding an extra antenna connection and that compatibility to advance the system for maybe other RF modems in the future. And also there is a video connection. The video connection of the antenna itself goes internally. It goes inside and it connects to the FPVC module. And the FPVC module, which the basic and the advanced, they both have a video receiver inside of them. And if you have the FPVC module with a video receiver inside the system, the RF signal goes to that antenna connection. If you take it out, it works on internal chip antenna. So the 5.8 gigahertz video receiver uses the internal antenna if the module is taken out. Now, I talked before about how this is an investment which you make when you buy the system. Unlike maybe buying a cheap remote control, which you will have to change later on as you advance with RC, you will most likely have to buy something more expensive. And even more expensive if you become like a scale flyer or maybe a FPV, or even more advanced for UAV flights. Most people will change their remote controls based on their knowledge. With OSRC, you don't have to. You buy it once and you upgrade it as you go. So this also includes the channel count. Now, normally, as you know, when you purchase a remote control, you also know the channel count of the remote control itself. For example, an 8-channel RC transmitter will do 8 channels on the receiver, a 16-channel, and so on. Now, the OSRC system itself can send up to 16 real-time PPM channels for any module which can support it. For example, a 16-channel high-tech Futaba or some other system. And it also will send the same 16 real-time channels through its own RF modem system which is built inside. Now, after that, we go to digital channels, and the digital channels go to up to 40. Well, why 40? I don't know. I just limited myself to 40 because, well, it can go higher, it can be lower, and also the channel count can be adjusted in the user interface. But I thought 40 would be a nice round number. Not that you will ever need 40 channels, but for now, that's the limit which is officially clarified for OSRC. So as far as channel count goes, you can set up the channel count you need and use that without ever worrying about running out of channels for your system. Now, a lot of people saw on the video the moving sticks. Now, why do the sticks move? First of all, let me talk about the internal assembly of the sticks. Unlike a normal remote control, the internal mechanism of the sticks themselves is completely different. And I made it different because I made it fit the specifications which I wanted OSRC to have. Now, you may know that there are some specs for transmitters which specify that the sticks are ball bearings, and that's supposed to make the motion very smooth. Now, the OSRC sticks are also ball bearings, and they are ball bearings on the X and the Y axis. And what makes this different from any other stick assembly is that internally OSRC sticks do not use pods. And so when you are actually moving the sticks, the only places where the sticks are touching the assembly itself are on the ball bearings, because the signal itself works on an optical encoder. Let me show you what I mean. Okay, so I have my parts bin here so I can show you. Now, internally, this is what you will find. This is an optical encoder. This one has 1024 pulses per revolution. These encoders are very gentle, so when I'm assembling this stuff, it's very delicate. Now, these optical encoders, they do not touch in any way the system itself, but besides that, the resolution is multiplied because the encoders are optically, they are mechanically geared up, so that when you're actually moving the stick, the encoder spins twice as much. Now, technically, the servos which are now on the market, some are digital, some are not digital, some have encoders inside, some don't. Well, I just chose that method because it's cleaner, it has more, I wouldn't say advantages, but it's just, I don't know, it's the path I chose to use. I was thinking about doing analog sticks as well, but for now, I like the idea that the only points on which the stick is moving is on the ball bearings, and the actual signal part is optical, and it's digital, and it's clean, and doesn't touch the assembly itself. So it's just the way I wanted to design it. There are no pots inside the stick itself, and I like the way it works, and it works fine, and it may present a lot of possibilities in the future. So that's as far as the signal of the sticks. Now, the motion. Why are the sticks moving? Okay, so let me tell you how I was thinking about it when I was building it. Now, when you are flying for the first time, or when a beginner is flying a plane for the first time, even when I was learning to fly, I always watched how the pros are doing it, and I was watching how the sticks are moving. Another thing which I used to do a lot is to go online or to go onto the flight simulators, and the flight simulators are showing you how the sticks are moving while they are flying. And although naturally every plane, every model has its own setup, the sticks themselves are basically moving the same way in most cases. So one of the features which I wanted to have is for a professional to record its movements, his movements or her movements, excuse me, and then the beginner can play back those movements and see how something is moving, and at the same time have still control on the plane. So for example, if you want to fly it and just learn how to fly it and then perform a trick, you can just assign it to a switch and the stick will move it and do it for you. But at the same time, it has feedback, so you can still move your stick the way you want it to, and the remote control will guide you through the movement as you go. This is one feature. Another very useful feature would be, because not would be, it already works. So another feature which the system does is the wireless training mode. In the wireless training mode, the remote control which the master trainer has is remotely connected to a second OSRC which the learning flyer has. And while the trainer is moving his sticks and flying the plane, on the trainee, the remote control is actually moving the sticks the same way, so he can let the hands off the remote control and he will see how the sticks are moving and take over the flight at any time. So it's basically the same way as a cockpit of a plane would be, which has a wheel on the left, a control on the right, and either one of the flyers can take over. So it's all done wirelessly, and you can just let go of the sticks and the trainer will continue to fly the plane. And this feature also introduces to some other features like the takeover. For example, if I have an OSRC and you have an OSRC, and I'm flying plane, and you come to the flying ground and just want to take over the plane, you can flip a switch, and I will take over your flight without even landing it, without connecting any wires, without doing anything else. Now, there are no conflicts with this because the OSRC system works digitally if you choose the RF modems which are inside the system itself. So besides the hopping frequencies of the modem, besides the encoding and the encryption of the signal, and besides the channels of the RF modem, there are also passwords which are on top of that for each system, and specific IDs. So without a password, an ID, a decryption, you cannot take over the flight. I mean, even if you are on the same frequency, even if you have set up your remote control the exact same way as the other guy, without the password, without the ID, nothing will happen. So I developed a system of friends, which basically you scan for other OSRCs in the area. There is a menu in the user interface which I describe. I will post a link to documentation on the website. You can see it in more detail. There are friend lists which the remote control will scan for, and you can add those friends to the system, and it will recognize it the next time you fly, so you can take over a flight and do a lot of other things. Additionally, because the system is wireless, you can transfer your settings to someone else wirelessly to your friend, and the whole friend list feature creates a lot of other opportunities. Now, let's talk about other things, like the model count. Now, because the system itself, the basic setup, works on a microcontroller, and there is a limited memory. Not that it couldn't be more models, but the number on which I stopped was 100. So the basic system, no matter how low it's configured, will have 100 models as a maximum, and that will save your exponentials, your mixes, and everything else for each model. Also, when you get like the FPVC system with a big screen and the Android processing system, the models become unlimited, because then you are not using the interface on the screen anymore, but you're using the Android user interface. You will be able to find more details about that on the website. Sorry if it's not complete yet. I just don't have time to write everything and do everything at the same time. So if it's not there, it will be there. Just be patient. Now, besides the models, I know that a lot of remote controls have, let's say, a plane mode, a heli, and let's say a glider. OSRC, because it's modular and I built the system, there is no reason to be limited to anything since it's open source. So the modes which for models which I built are for a plane, for a heli, car, a boat, a robot, a UAV, and a DIY. Now each model setup is somewhat different from others. For example, for a heli you would have your swash plate setups, for a plane you would have your flaperons, for a car you would have your brakings, and let's say for a robot you can customize completely everything as you want it to be. There are a lot of different setups for each mode, but as far as you should know, for the time being, those are the models which are programmed into the system. It's for a plane, heli, car, boat, robot, UAV, and DIY. In some point I will discuss more of those features, but for now, this is what you should know. Now, let's talk about the assignments. Now, I know a lot of systems saying that the switches, the buttons, you can assign them to anything you like. But when you are starting to assign those things, it becomes clear that even though you can assign it to different things, still your assignments are quite limited. The way I built, I spent a lot of time on just this feature on the switch assignments. And the way this works is that now everything is assignable to whatever you want it to be. You will find in the description of this video a link to the switch assignment menu. Now, the way this works is that you have functions. These functions can be a takeover function, or a assign directly to channel function or override the channel function. There are many functions which can be assigned, but the principle is that you can even assign the right stick, for example, to a different channel. You can assign the right stick to be your user interface. You can assign it to anything you like. It doesn't matter. Now, besides that, it creates a lot of other functions which are very, very useful. For example, let's say you have a channel assigned to this pod. Now, you have trimmed your pod, but at some point you want to override that channel. So you can assign an override function, and when you flip a switch, that channel would go to a certain position which you would set in the menu. The menu is described in the link of this video. Another great feature which it's helpful in some cases is, for example, to assign increments to a channel. So, for example, you want to assign, let's say you assign this switch to a channel 5, and you want each time you go up on the switch, the channel will go certain positions up. So you go up, 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 and it will rotate the same way. Or for example, you want to override that as it goes up, you can do that. There are a lot of different things and variations which you can do. Also, you can, for example, assign a timer, and the timer will activate something on your channel when you want it to. So you flip a switch, the channel will wait for a certain period of time, and then it will do a function. There are a lot of different things which you can do, but all these buttons, even though the user interface is set up for certain buttons, for example, right, left, as you will see, let me, everyone likes that, I know. So, sorry for the sticks now, but I just made the feedback is very low because I was playing around with the different features. So when it's centering the sticks now, it's very weak. It's just a function which I will probably fix later on. It's just that I was playing around with some new features, so I forgot to put that on. Now, for example, you see now the modes and the user interface. It's assigned to, let's say, this cluster here, and the enter is on this part here, and the back button is here. But all that can be assigned to different buttons. Even these switches can be assigned to the menu. You can do whatever you want. The back switches can be assigned. Even the trims, you can assign them to different things. So it's a very, very useful function to have. Okay, that's about the switches. Now, let's go about some different things of the system itself. Of course, besides the buzzer, you also have a vibrator inside the remote control. And the vibrator is very useful, especially when you're flying electric, or even if you're flying nitro. For example, you can assign the timer to activate your buzzer, also to activate your channel, the way I explained before, but also you can assign it to the vibrator. So when you're flying and everything is buzzing and other people are flying around you, the remote control will vibrate at the same time, so you'll feel it, your time is up, you have to come down. It's a small detail, but it's very useful because I found it that when flying electric, you know, sometimes, especially when you have helicopters, even for a split of a second, you don't have perhaps time to look at the screen. So you just need to know when your battery is going to go down, and you need a notification. Maybe you won't hear it through the buzzer, but you'll definitely hear it through the vibrator. So that's as far as the vibrator goes. Now, on the battery of the system. The battery compartment houses inside a 3650 milliamp lithium polymer 7.4 volt battery. Now this battery is, well, the compartment for the batteries was designed specifically for a certain battery that I selected for the remote control. And those 7.4 volts go up to 9 or 10 volts for different RF modules. They do a lot of different functions because the system itself is working like a computer. So you have your power supply unit, you have your processing unit, and different other things. So the battery itself is a lithium polymer. You can put a different battery on it. And the good thing about the system itself, it has a recharger inside the remote control. So you can apply a 12-volt power to the system, and it will charge it no matter what battery you have. It's not a balanced charge, but it will charge it normally, and it has a lot of features for charging. Let's say it doesn't overcharge, it doesn't undercharge the battery. Even the battery itself has protection on top of it, so it doesn't discharge too much, it doesn't overcharge. So as far as battery goes, the default battery which the system has is 3650 milliamp at 7.4 volts. Now let's talk about the FPVC units. I built the OSRC system to have the FPVC units. FPVC units or modules are units which I created to expand the functionality of the remote control. When I say expand, besides the buttons, besides the additional analog sticks, you can also have additional processing power on these systems. Now, there are three types of FPVC modules. You have your plain FPVC module. The plain FPVC module is basically what you see here, but it doesn't have any FPV hardware. So it doesn't have RF, it doesn't have video reception. It's basically an expander, and it just sits on top of your system, and it just adds the default buttons which you can assign. That's the plain, which basically it has the buttons, and you can take it off, but it won't work without a power supply. Then we go to the FPVC basic. The FPVC basic, which is this one which I have now, besides the buttons, the analog sticks, it also houses inside the video receiver, which is a 5.8 gigahertz video receiver, which has up to 8 different channels which you can view. Now, this video receiver, it outputs its signal video out to this jack here, and this jack gives you the video, the audio, and power for your goggles or anything else you want to connect to it. And it also has a USB for configuration, for upgrades and stuff like that. Also, it houses the battery, because there is also an RF modem inside this module. So this module communicates wirelessly to OSRC. Sorry. When I talk wirelessly, I mean that if you choose to have the OSRC RF system in the internal one, not the PPM modules from Hutaba or Hitech or JR, you are unlimiting your device to many different features. For example, because and this is probably the time where we are talking about the RF cloud. Now, the way this works, is the RF cloud. Each RF modem from the OSRC system becomes something like a cellular tower on a cell network. So let's say the OSRC system has a modem inside, the FPVC module has an RF modem inside. You may have a joystick with an RF modem inside, which may be done in the future. All these things are interconnected with the OSRC and are wireless, and you can add or remove hardware as you go. Even the model controllers, which are basically the part of the OSRC internal RF system, which is on the model, it's also connected to the same network. So all these things, besides the network, they create a higher range. So the more systems, the RF systems you have, the higher your range becomes, because they create a cell of devices which communicate with themselves. Also, for example, you can have, let's say you're standing on one mountain and a friend of yours standing 1 kilometer on another mountain. You can fly a plane towards him, and he will take over that plane and fly it farther, and another person can take over that. Or the other way around, you can assign, for example, a helicopter to hover and take over your quadcopter or multicopter and fly on top of that, while OSRC is controlling your helicopter as well. So a lot of features become available. There are some discussions about this in the forums. there will be a lot of discussions about it in the future, but for now the RF cloud system, that's its advantage, is that it creates a completely new network of RF devices for your OSRC system. Now, besides the FPVC basic, I took the liberty to, because a lot of people were, I don't know why, because I mean, you know, I'm designing these things and it takes a lot of time to test them and to develop them. Perhaps I forget to just show them to you. So I took the liberty and took the FPVC Advanced apart so you can see it. Now the FPVC Advanced, I'm just showing you some of it, because this board here is I disassembled it because I was working on it, but it houses the video receiver, it houses the RF modem, which as you can see here has a chip antenna, which also well, the RF is connected to a chip antenna, the video receiver connects to the antenna on the OSRC, and also has on the other side the chip antenna. The main processing module, which is a 1 GHz processor system, complete system, it has audio, it has hardware, video acceleration. Basically, it's a mobile device within a module. So this whole Android operating system, which is on this, which works on a 4-inch LCD, which is touchscreen. You will have a lot of features which come extra for FPVC Advanced, and you can read about that on the OSRC website, because there are too many things which have to be discussed about FPVC Advanced, and I can't cover everything here. So we shall just talk about the hardware. Now on FPVC Advanced, you also have the GSM modem, which is also a GPS. You can see here the GSM antenna and the GPS, which is on the enclosure itself. And you have naturally your SIM card, your micro SD, USB buttons. It's a complete, let's say, computer on top of your OSRC system. So it gives you a lot of advantages, especially in the field of FPV, where, for example, you want to see a map on your screen and you want to see a video from your plane on the screen at the same time. Even at waypoints as you fly, you can do all that and a lot more. You can even play Crazy Birds on it if you want, because it's Android 4.1. So besides the operating system itself, there are a lot of apps which I'm still developing, and a lot of other people are developing for Android, so it has a lot of compatibility for that. But FPVC Advanced also gives you the ability to control a lot of other features on a big screen, and basically your smaller screen becomes secondary. So that's as far as FPVC Advanced go. A lot of people were asking me about the video signal, how you are processing the video signal on FPVC Advanced. Now, as I said before, FPVC Basic just outputs the signal to the jack here. So you can connect your monitor or goggles or whatever you want. Now, FPVC Advanced, the video signal, it connects to the processor for Android, basically like a camera on your mobile phone. So the analog signal from your video receiver goes into an analog to digital converter and goes to the processor, the CPU on the device, and you will see the video the same way as you see on your mobile phone. And also you have the same video out jack to connect your goggles or something else. Okay, now this is as far as I will go for the OSRC. I will give you another look around it so you can just admire its beauty. Here you go. A lot of things made this thing possible. Now, of course, there are trims here. You can also see there are some RGB LEDs here which are indicating a lot of different modes as you fly. For example, takeover, green LED, status. I made some LEDs just for status, so you can some basic things you can just see them through LEDs and don't have to browse through the LCD in order to see something. Now, this is as far as OSRC. Now let's put it aside for a second. I put it like that so you can have a better look. And let's talk about the model controllers, the part of the system which is on the plane or on the model itself. Now, well, of course, as you can see here, it's also XB, and it has a controller on top of that. Basically, what this is, you could think of it as a receiver on your model, but it's not. It's not, because this is a RF modem, and it's not a receiver, because as we said before, OSRC is not a transmitter. It's a receiver and a transmitter. It's a complete RC system. It's a completely new generation of RC remote controls. So although this can be thought of as a receiver, because remember we talked about channels before, and we said that you can have up to 40 channels on your control. But how will you use those 40 channels on your model? Because as you can see here, you have only 10 connections. Now, the way I built this is that you can expand this. So when you buy, let's say, one model controller, you can expand, besides the 10 channels which are already on top of this, you can expand it to 20, to 16, to even more channels if you want to afterwards, through these ports here. You can also, besides the channel expansion, you can connect to the model controller sensors. Now, for example, this is the Mark I sensor module. As you can see here, the connection, basically, there is a wire connection which goes from here and connects to the model controller. Let's open it inside so you can see it better. Now, this sensor module has a triple axis accelerometer, triple axis gyro, and triple axis compass inside. If you connect this to the model controller, this becomes almost a UAV. I am saying almost because there are more to come, so keep on watching this video. Now, just these two things already are solving many problems. For example, if you are flying helicopters, you can use this. You can use the gyro on this to stabilize your tail and not have a secondary gyro for your tail. You can use, besides the gyro, you can use the compass as an option, and you can also use the accelerometer for your tilt and yaw. So all those features of the sensor, you can assign them also to different channels and mix those. So besides, for example, flybarless setups can use this as well, besides the gyros for your tail. So even with this, as you can see, we already expanded to do different modules, and you already covered a completely large span of models. For example, you can also fly a plane, and you can assign your ailerons, your elevators, or whatever you want to assign to your gyros, accelerometers, or compass, and have your mixes work as you want them to. Now, besides these two things, we also have the FPV module. Now, the FPV module has a GPS, a GSM, and a video transmitter module inside. Let's open it and see how it works. Now, let me open it up so we can see it. I'm having all these enclosures just opened up for you so you can see them easily. I mean, it's all screwed on and it's very tight, but for now I just had it open so I can show it to you. Now, it has also the GSM and GPS module inside. As you can see, the GSM antenna here. The video transmitter, which transmits your signal to the FPVC advanced or basic module. And you have your SIM card here. Now, these three things, as you can imagine, create something very special. And let me show you what that special is. Now, besides expanding your channels to more than 8, you can connect your sensor module to your FPV module, and your FPV module to your model controller. And this gives you a UAV system. Now, I must admit, the whole UAV system for OSRC is possible as far as hardware goes. As you can see, it has everything you need to have for a UAV to work properly. You have your sensors, you have your GSM and GPS, you have your RF channels, everything you need in order to have it as UAV. For the time being though, I am mostly concentrated on the remote control part of the system, because there are a lot of features which already are very unique to OSRC and on which for the time being we are going to concentrate. But as hardware goes, this system may, or I could say most probably will become a UAV system as well in the future. Now for the time being it's not as important for me, because there are a lot of already very good UAV systems out there, and OSRC was created as a remote control system first, as everything else later on. So it can already host softwares which are based for other UAV hardware, which some of them are open source, some of them are not. But for example, even without the UAV functionality, you can already have your FPV stuff, you can already have your telemetry. Even if you lose your RF with this module, you can still control your model through GSM, as long as you have GSM coverage, and as long as you have the FPVC Advanced, because remember, FPVC Advanced is the one which has the GSM module. So FPVC Basic doesn't. FPVC Basic works with the RF system for OSRC. Now there is a very nice comparison chart which I will also put a link to on the video, which will explain what's best for what situation, so you can choose for yourself. But this is as far as we are going to go today. Now another thing I wanted to show you very quickly are some of the shoulder switches which I made for OSRC. For example, these are the basic shoulder switches. This is the pod shoulder switch. Basically, it gives you 3 switches in one pod. So if you put this on, you will have, besides the other 2 which are on the system, you will have an extra pod on the system. Now, besides this pod, we have the Devastator. I like to call it Devastator because this is as many switches as I could put on the shoulder. Here you have the 4 switches which are already on the system. Also, a nice thing to note, I like to do things so there is some kind of consistency. So because also other controls have this, the switches, the way I have it configured, they are not all the same. So it's not just on-off. For example, on the right side, you have the first one goes one side or the other. This one is for your mode selection. Now, one thing I forgot to mention is that, let's say a different remote control system may have up to 3 modes, flight modes, which you can choose from. On OSRC, you can have up to 15 modes. You can have more, but it's a memory limitation for the microcontroller. The way this works is you can assign your flight modes, and you just can scroll through them. So you can have as many as you want. Now, this also is very nice because, as an example, I will give you a microcopter or an ardocopter, where you have to select different flight modes in order to do your loiter or to do your point flybys. And for those, you need to have the switches which can be assigned to different positions. When you assign it on OSRC, you can assign it and scroll through them. So for example, you can have your loiter, then you go scroll down, you scroll down, you scroll down, and you scroll down as much as you need to, and you set this up on the system itself for as much as you need it to be. So that's one feature. Now, the third switch is also up and down, and the fourth one is also up and down. Now, on this side is different. On this side, we have these 2 which are on and off. But this one scrolls up and it just stays down. I just made them different so that you can decide for yourself in which situations you want to use it. Now, this is as far as the basic unit goes. For the pod shoulders, you have this on-off. You also have this scrolling one here, and you have on-off also. And on the Devastator, the Devastator is different because it has these 2 different switches, which are, I made them especially this way because these switches can be locked. For example, this one, if you lock it in a different position, it stays that way. Also, this one is a normal switch, but it just has a bigger paw there, so you can assign, I don't know, maybe brakes or something to it. I just made a variation just for you to have. And also you can see here with the other switches which are on this module. Now, this setup here, and sorry for having FPVC advanced disassembled, you can see pictures of it on the website. I was just playing around with it. I have another one which I'm working on because I'm also constantly working on the Linux system as well as on the operating system on the remote control itself. So I hope I explained as much as I could for everyone and clarified a lot of things about OSRC. You can find more information on the website. Also, please like this video if you like it. Also, visit the Facebook site. I'm hanging out mostly on Facebook for every day-to-day stuff, uploading pictures there also of me, things I do. Also Twitter, if something pops up on YouTube or if something pops up on Facebook, it also goes to Twitter, so check that out as well through the website. What else did I forget? Don't forget the links which are going to be on this description to different manuals. Again, forgive me if something is not complete. It's just that I didn't have a lot of time to finish everything. As you can see from the status of the project, currently there are some limitations to the funds, and funds means time, so I don't have much to work with. So there is a campaign going now. If you are watching this video while this campaign on Indiegogo is going, you can visit that and help if you like. Also post your comments in the forum for OSRC. I'm also aware. I will try to help as much as I can, and thank you for watching. I hope I explained as much as you wanted me to explain. Unfortunately, I can't cover everything, but there will be many videos to come. So thank you for watching once again, and check it out. Hope you like the OSRC. Thank you.